A very good morning, good afternoon, good evening to all the students, participants and my friends for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you are all aware, so there are three broad in-depth coverage for this course, which is for 30 hours, which is spread over 60 lectures, each week having 5 lectures, half an hour each. So, the three broad topics again I am saying as I do for each class as it starts. The first topic is forecasting and averaging techniques, second one is regression models and third one is time series analysis. Now, from today onwards, we will start the topic of multiple linear regression. Now, even if the topic is multiple linear regression, which is the second part of this NPTEL MOOC course, there will be different other concepts also covered in multiple linear regression. Actually, I can say it is a regression concept which will cover. Multiple linear regression is just a part, but even though we will be covering much more than that, again I am saying all as you have seen in the first part, which was forecasting, there would not be any theory, only the concepts, no proofs and the problem solving. And the problem solving will all be done using Excel sheet. Now, why this second topic is being considered regression model and what is the fundamental difference between the concept of forecasting, I will come to that very soon. So, this is week 5, 25th lecture. So, we have already covered 24 lectures out of the 60 for averaging techniques and forecasting. So, we will start off the regression models. So, what will be the coverage for today's lecture? It will be, we will give a introduction. Introduction will continue for a little bit long in this second part than with respect to forecasting concept, whatever was there in the initial part of the first so called major topic, which was forecasting, and there are reasons for that. I will come to that. So, there will be explanation with diagrams and obviously as usual we will consider different type of problems also. Now, what is multiple linear regression? And if you have heard me carefully, which I made a statement few minutes back, that what is the fundamental difference between regression and forecasting model. Now, in forecasting model, if you have noticed, there was only one data, set of data, not one single data, but set of data, means they were denoted by y and they were dependent on time. So, it can be say for example, number of airline passengers moving, it can be say for example, the rainfall for a country per month, it can be say for example, the concept of the production of one particular chemicals in a factory, it can be say for example, the amount of tonnage moving through Suez Canal. If you remember, I had mentioned that. It can be say for example, number of so called the oil production by OPEC countries. Now, in all these things, the set of data points was only related to one variable which we want to study, and we always denoted it by y with the corresponding suffix. And when you are plotting, if you remember, we always plotted time along the x axis and that value y along the y axis, and based on different models, whatever they were, like moving average, exponential moving average, which one parameter non-adaptive, it is not changing, multiple parameters non-adaptive, one parameter adaptive, multiple parameter adaptive, then halt linear method, halt winter method, considering additive seasonality, multiplicative seasonality on all these things. Now, in regression, you want to regress. That means basically you want to utilize the past data in order to predict, or for the word forecast, prediction, all these things would be changed or used interchangeably, but fundamentally there is a difference. So, do not be too much bothered about that. So, forecasting was the concept used in the first part. Here we will basically use the prediction or even forecasting, as I mentioned it few minutes back. Now, here you are trying to regress and try to find out the value of a dependent variable which is denoted by y, and based on which is here, if you see it here, it is marked here. So, you have a dependent variable which is denoted by y, and it is being found out the estimated value of that y for the future time period is based on a set of independent variables. And if you notice here, x is bold because it is a vector. Now, why it is a vector, depending on the case, it can be if there are a number of x variables which you are trying to utilize to find out why, it can be a matrix also. So, why it is a matrix, why it is a vector, we will come to that. Now, vector would be very easy to understand if you have, say for example, n number of data points. Similarly, y would also be a vector. How you denote whether a column vector or row vector will depend on the nomenclature, how you are basically going to denote it. But in case if x is a matrix, it would basically mean that there are values of more than one x. Now, what would be those more than one x? We will come to that later on. So, as I mentioned, fundamental difference being forecasting mean is basically forecast on its own based on the values of past data of y, like yt minus 1, yt minus 2, yt minus 3, while here in regression y will be denoted and utilizing the values of x from the past, we will basically try to predict for y. So, as the concept of multiple linear regression is basically a statistical technique which is used to forecast or predict a dependent variable y based on independent variable set of variable x. Now, there will be a lot of assumptions here, and assumptions would be making sense as we proceed and solve the problems later on. Not today, we will basically try to solve the problems by next to next class, because there is some concept we have to basically follow. Now, when I am talking about the concept, whichever are important I will highlight, but generally the discussion will continue such that there is a flow in the assumptions, flow in the explanation, such that you understand and utilize the models accordingly. In order that a prediction of forecasting, or in the case of multiple linear regression, is accurate, we ensure through proper assumptions and subsequent calculations that the error of prediction or forecasting, or what we want to basically regress, is minimized. The concept, how you want to do that, what you want to minimize, that idea remains the same as in forecasting. So, is it in regression. Now, another point which is important, if you remember, I mentioned few minutes back that if x is only one variable, obviously there can be many data points, then it is basically called simple linear regression, because there is only one x which is independent, based on which you will try to basically find out the value of y, which is the dependent variable. But if the number of x is more than one, each having, say for example, same number of data points, then obviously we will go into the realm or in the area of multiple linear regression, because there are multiple variables based on which you will regress and find out the value of y. We will come to that within few minutes. Now, in multiple linear regression, a model or theory is not confirmed until unless it is made to include every possibility. Now, you may be thinking, what does every possibility mean? Say for example, I want to predict the temperature at a particular place based on, say for example, the time of the day. So, each day at 9 o'clock in the morning, I am measuring the temperature. So, temperature may depend on humidity, may depend on wind speed, may depend on, say for example, pressure, atmospheric pressure. So, if I basically fix the latitude, longitude which is fixed, and as the pressure change, atmospheric pressure changes, it can change. If there is, say for example, there is wind speed, it is wind speed is very high, very low, or if the concept of as I said, humidity is there. So, based on that, when I want to find out the temperature, so here I see it will be consider there are two variables which are being utilized to find out the temperature, because latitude longitude is fixed and 9 o'clock at that time is fixed. So, obviously, if I consider the humidity and the wind speed as two variables, then in that case it will be a multiple linear regression based on two variables. I am trying to basically find out the dependent variable y, which is the temperature. Consider another thing, say for example, I want to find out the weight of a person, and based on his or her height, consider I am only taking the male. So, based on his height and also considering the bone structure the person has, because doctors use the body mass index to find out what is the obesity sense of that person, so on and so forth. So, say for example, if I am only utilizing the height of the person based on which I find out the weight, which means there is only one variable, in that case it will be a simple linear regression. Consider another thing, say for example, I want to find out the price of a product based on, say for example, demand, supply, the inflation rate, and there are other variables. So, obviously, in that case, if there are, as the number of x is more than 1, it will be a multiple linear regression. Now, if you notice one thing, and this point will become very clear as we proceed into the time series analysis, the concept of regression, the concept of forecasting, the examples which we have taken can be from on the variety of environment. So, it can be, as you remember, for forecasting we had mentioned, it can be the tonnage, it can be the number of passengers moving, it can be, say for example, the number of barrels of oil production. So, it can be anything. Similarly, for the case of regression like temperature, it can be based on trying to find out the oil production. But when we come to the concept of time series, specific examples will be more in the area of financial time series and economic time series, because obviously time series can be utilized for other topics also, but the realm and the application of time series is more prevalent for financial data. So, this I thought I will just mention. Now, if you remember the first point which you are discussing, so whenever you are trying to find out the temperature based on, say for example, humidity, based on wind speed, so they can be external factors also which may affect the temperature. So, we will consider the total amount of variability which is there in x1 and x2, which are the two variables based on which we are trying to find out the value of y. It need not be 100%. That means, all of the prediction, all of trying to find out the total temperature may not only depend on these two variables. There would be some white noise, there would be some external factors. So, actually basically it would mean that whatever model you consider, there may be some white noise which would be affecting the reading, and this white noise is basically the factor based on which the error will come. So, if you remember, the main point was mentioned in the previous slide that you wanted to basically minimize the error. So, that means minimize the overall effect of the white noise, overall effect of the external sources, such that you are able to predict to the maximum possible extent. One should remember that a deterministic theory will be invalidated by a single contradictory observation in case the value of the observation does not meet for a deterministic model. Hence, the introduction of stochastic elements into the model changes it from an exact statement into a probabilistic description about the expected outcome and carries with it an important implication. Now, why I am basically laying stress on the word expected, in the sense is that whatever calculations or whatever model we try to utilize for the regression case, it will always point to the fact that we are trying to find out the expected value of y in such a way that the overall deviation of, so there is, again let me repeat. So, there is an expected value of y, but at each time when you measure there will be deviation. because depending on the white noise, depending on the environment, and how x1 x2 x3 variables are varying. So there the value of y will change, and obviously it would not be exactly equal to the expected value. So our main concern is basically to minimize this deviation based on the expected value. That is what it says, that we want to find out the expected value of y, based on which we will do all our studies for the regression models, and that will become clear as we do the problems, as we show the diagrams, and also solve the problems in such a way that for the two-dimensional case we are able to view how the expected line would look like. Only a preponderance of contradictory evidence can convincingly invalidate the probabilistic model. So, if you have a probabilistic model, and if for future readings, if the probabilistic model is being nullified maximum number of times, then obviously the level of confidence which you will have on the probabilistic model would be very low. What constitutes a preponderance of contradictory evidence is a matter of interpretation based on how you want to judge, how you want to analyze the model. That will become important, and for that we will basically be considering the concept of level of confidence, or the level which we have on that model, and I will come to that from the probabilistic point of view. Probabilistic model is less precise, but at the same time more robust depending on the level of confidence the main person who is utilizing that model is willing to give to that model. So, obviously, the level of confidence, more robust it is, more lowered the sharper the bounds, more closer the bounds would be based on your level of confidence, such that you are able to predict the actual value with respect to the expected value to the maximum possible extent, because the expected value is fixed and the actual value which you find out will depend on the data point and it can change. But if the dispersion or the movement of the actual value in and around the expected value is as low as possible, then obviously the model is very robust and it gives you good results. Few relevant examples, we will solve problems, so do not worry. So, let us proceed. So, the example can be, what are the likely effects of labor supply behavior of proposed negative income taxes. So, as income taxes increase decrease, what effect does it have on the labor supply? Does it increase, does it decrease, or does it remain constant? Second example being, so if you read the first example, it is related to effect on the labor supply, and the effect is coming from the income tax. So, there may be some financial implication or economic data, but the actual study which you are doing is based on labor supply in numbers. The second example is, does a monetary policy regime that is strongly oriented towards controlling inflation impose a real cost? So, here obviously financial implications are there, because the problem is in the area of finance and economics. So, the main the idea is, if we have a monetary policy regime changing, does it have a positive or a negative effect on the real cost of goods? The third example is, does attending a good college bring an expected payoff in lifetime expected income, which is sufficient to justify higher tuition? Which means that if you have a higher education level, does it mean the person would have a much better job? And if that is the case, does it basically imply that the tuition fees can be increased? Which means that we want to find out that if the level of education is better, if the quality of education is better, does it have a positive effect on the income of that person? So, again this is an example which is not directly related to finance, but somehow you can find out all the three examples which have been given are different ways how regression models can be utilized. Let us continue discussing more examples. The fourth one is, does a voluntary training program produce tangible benefits? Can these benefits be accurately measured? That means somebody is undergoing some training program, and does it have a positive or negative effect on the type of job the person is going to do, or the type of jobs he or she will get, and also what would it have an implication on the salary or the weekly wages of that person. So, this is another type of problem which can be handled. The other three problems are, I will just read it. Do smaller class size bring real benefits in student performance, depending on the more attention they may get from the tutors, from the faculty members, from the professors? Another example is, which I have discussed, does humidity predict higher temperature? And the example I have been discussing, that how you can utilize humidity, maybe utilize wind speed to find out the temperature at a particular place depending on latitude and longitude. Does obesity lead to health problems? Again, the same type of problem I have discussed. So it was basically based on the the weight depending on the structure and the height. So here, for the last example, as I mentioned, the body mass index can be utilized as a good way to predict what is the level of obesity a person has. And here you can utilize different type of simple regression models or even multiple linear regression models. Now, if you remember, I had mentioned that in the area of regression there would be some assumptions, and these assumptions are very important. First is linear relationship between independent y and dependent x variables. Now, if you see here, I will use the orange color. So, y has a suffix n cross 1, even though it is bold, but remember that n cross 1 basically means y is a vector, a column vector. So, when I am denoting y, I will use the violet color here. So, y n cross 1 means basically you have a column vector where the first value is y1 and the last value is yn, which means it has got n number of rows and 1 number of column. Now, when I come to x, it is given of a dimension n cross k, which means that if I have, I will use a different color. So, let me use, say for example, green. So, if I have x, so it will be of size n cross k. So, n cross k means there are n number of rows and k number of columns. So, what would mean is that you would basically have x 1 1, and what is 1 1, I will come to that within few minutes. And the last one is basically you will have x n 1, and in this last element in first row you will have basically x 1 k, and the last element which is in the last right hand bottom would be x n into k. Now, what does it mean? So, if I only concentrate on the first column, let me use the red one. So, first column, the suffix are given x 1 1 till x n 1. Now, x 1 1 to x n 1 means I am taking all the n readings for the first variable x 1. So, in many of the books you can find the nomenclature of x 1 1, x 1 n can be replaced by x 1 n also, not n 1. But do not be too much bothered, because once you understand the general implication how it is written, things would become very easy. So, as I was reading, x 1 1 to x n 1 in the first column basically denotes the first random variable x 1 for its reading 1 to n. So, I am taking the first random variable and I am taking n readings of them. Similarly, when I go to the second column, I will use blue one. So, that would be given by x 1 2, and the last for that column would basically be x n 2. What does it mean? It means the second random variable 2 and all its readings from 1 to n. Similarly, when I come to the last column, which I will mark in tick mark in violet, the variables are given by x 1 k to x n k, which means that is for the kth variable or random variable x, all the readings corresponding to that random variable, and the number of readings is 1 to n. Now, it would be immediately easily understood that if n is the number of reading, then k would be the number of random variables which you have, which means that I am trying to utilize k number of such x's, each being of n number of values which are there, in order to predict for y. So, that is why here it means there is really a relationship between the independent and the dependent variable, independent being y and dependent being x. Now, coming back to the concept of linear dependence means that the rate of change of x, whether x is increasing or decreasing, would have a linear effect on y. There is no non-linear relationship. Now, you will find out later that we will be utilizing maybe not utilizing x, we may be utilizing x square of ln of x, but do not be confused by that, because the concept of linearity will continue holding, and what actually linearity means, I will come to that in more details. The second one is basically, in general, we mean that all the different independent variables, that is x's, are themselves independent, which means that if you have seen the matrix of x n cross k, which means technically all the k number of random variables of x are independent of each other. So, independent of each other basically would mean that when you want to find out the rank of the matrix of x n cross k, then obviously it would basically be considered, forget about n, the rank would basically be of the order k, because all these k number of random variables x's are independent of each other. What does it mean from the concept of matrix algebra? Very simply, it means that none of the rows or the columns can be expressed as linear combination of the other. Now, it has got much simpler consequence in the case of simple algebra. Say for example, I want to solve two problems in the sense I want to solve find out the values of two variables, consider them as x1 and x2, and consider the equation is written as this. So, you have 2x1 plus 2x2 is equal to, say for example, 4, and another you have 3x1 plus x2 is equal to, say for example, 4. Now, if I consider the random variables here and I solve them, then if you solve this technically, so if I multiply the second one by 2 and subtract from the first, so obviously it will be 2x1 minus 6x1. So, 2x2 and this is also multiplied by 2. So, this cancels out. On the right hand side you will have 4 minus 2 into 4, which is 8. So, basically you will have minus, I am going here. So, you will basically have minus 4x1 is equal to minus 4, which means x1 is plus 1. So, if I put x1 as plus 1, immediately we will get x2 as also as plus 1. That means there is unique solutions for x1 and x2. But when I have this sort of equation and I will erase it here, consider I write is as this. Say for example, this I will use the same color. Consider I have the equation as this. So, the second equation has been changed to 3x1 plus 3x2 is equal to 6. In that case, if you want to find out, so obviously it would mean that when I want to solve it, technically I have to, let me write it much better in this way. So, basically what I do, just give me 1 minute, multiplied by 3 by 2, yes. So, the second equation is obtained when I multiply the first equation by 3 by 2. So, 3 by 2 into 2 is basically 3x1, then again 3 by 2 into 2 is equal to 3x2, and 3 by 2 into 4 basically would give me 6, which means each equation is dependent on the other. That means, utilizing these two equations, I am unable to find out the values of x1 and x2 uniquely. Now, when you basically convert that in the concept of matrix, it would mean that the rank has to be equal to k, or else any one of these x can be easily explained, and you can find out the convex combination of the others to basically find out the values of that particular x, which means the rank is now less than k. That is not allowed because it would mean that is dependence between the x values which are independent. So, I will just read it. In general, we mean that all the different independent variables are themselves independent, that is the matrix notation for multiple linear regression, the rows and or the columns are independent. So, with this I will end this class and continue more discussions. Again I am saying yes, there would be some theory, but that is more of on the conceptual part, and once I come to the problems it will be very easy for you to understand. And also remember, the problems will be solved in simple Excel. For 2 dimension it will be very easy to understand pictorially. For higher dimension we will solve the problems. In order to basically pictorially represent, I will try the 3-dimensional figures, and for the others I will try explaining verbally as far as possible. Thank you very much and have a nice day.